Hi, I'm Miles Borens. I work for Google as a developer advocate for Google Cloud Platform. Been participating in TC39 for just over 3 years.
My name is Michael Saboff. I work at Apple on the JavaScript core engine. Been attending TC39 since 2015, maybe?
My name is Mark Miller. I started on TC39 in 2007. While I was at Google, about 2 years ago, I left to form Agoric, which is a blockchain startup where we're going to be running JavaScript on blockchain. And I've been doing a lot of work to make the language better able to support more disciplined and more secure programming.
I'm Aki Braun. I work at PayPal. Well, I work at Braintree at PayPal. I've been on the committee since 2017, and I have been co-chair. This will be my second year.
Hi, I'm Rob Palmer. I work for Bloomberg, where I lead the JavaScript infrastructure and tooling team. I've been on the committee since 2018. And just this week, I became one of 4 co-chairs, like Aki here.
Hi, my name's Shane Carr. I've been on TC39 since 2018. I'm work at Google on the internationalization engineering team, and I lead the internationalization subcommittee for TC39, focusing on making JavaScript a language that's very friendly for international first applications.
And hi, I'm Justin Ridgewell. I also work for Google. I work on the AMP project, and I'm one of the core maintainers on Babel.
Wow, so many impressive people in the room. So the first question that pretty much a lot of people have asked is, what is the organization behind TC39 and what actually is TC39? Any one of you can answer that, I'm sure, very well.
I think I'll take this one. Okay, so TC39 is the 39th Technical Committee of ECMA International. ECMA International is a standards body. They are who publishes the ECMAScript standard once a year, which you may think about, ES 2015 changed a lot of things, sure, but every year now it gets published, 2016, 2017. ES 2020 will be published in July, I think, yeah. So ECMA is an organization made up of member organizations. It's a standards body that large corporations, small companies, and nonprofits and universities can all join. And once an organization has joined ECMA, they can send delegates, that's what we all are, delegates, to technical committees. I don't know if that actually explains what's behind TC39 or not.
That answers the question pretty well. So I'm sure you get a lot of features requests and features that are proposed and everything. How does a feature move through the committee, through the proposal process?
I'll take a crack at that. We have a stage process. In the documentation of stage 1 through stage 4, there is a stage 0. Computer scientists, we don't know how to count. We start counting at 0 instead of 1. But stage 0, stage 1 this is an idea that someone thinks would be good to add to the language. And stage 1 proposal basically says the committee thinks that this is worthwhile to consider adding to the language. Stage 2 is now in the step where you're going to look at spec text. So how you specify it, you define semantics and things like that. Stage 3 is where it's implemented by at least 2 implementations, and an implementation doesn't necessarily have to be, for example, the engine, a JavaScript engine side of a browser. It could be, for example, a Babel implementation. It could also be there's an embedded engine called XS. It could be in that engine as well. And stage 4, it's in the language. Stage 4 is synonymous with it's in the standard. And we say something stage 4 until it's produced in that standard. So there's stage 4 proposals that are going to be part of the ES 2020. And after 2020 is out, we won't call them stage 4. They're just in the language. So that's basically the process to go through. It's typically done by a champion that's going to take it, or champions. There could be more than one person, more than one delegate that's going to take it through that whole process. There's some debating on is this at each stage, is this something that we think is worthwhile? Are people going to use it? What are the use cases? Also, the semantics, do the semantics mesh well with the rest of the language, so on and so forth. So that's basically the process that we go through to put something in the language.
So were you going to say something?
I was just going to say, it's worth noting that our standard for whether or not we're going to tackle something in the first place is this new syntax or API something that we want to add. Is there a problem that we're going to solve, which I think is maybe a different approach than a lot of people assume that we make to making changes to language. We identify problems that need solving, and from there we decide how we're going to do that.
So I first heard about optional chaining, which I think is stage 4 now. But I first heard about that, I think, when it was stage 0, which was like 3-ish years ago or something, 2016. And so is that typical for something to take that long to go through stage 0 to stage 4? How long does something typically take?
Years. So I was actually one of the co-champions on optional chaining.
Thank you.
I actually saw there are Google internal documents suggesting optional chaining back in like 2012. The fact that we only finally produced the spec text for it and tried to go through the staging process starting in like 2016 or so. I think there was a little bit of infighting about what the scope of what we wanted to do with optional chaining and how far like the optionalness of the chain is. Where it ends, whether or not it should be undefined or null. So that took a little bit of extra time in order to work through. But then once we actually had like a concrete idea, we knew all of the solution to it, it only took maybe 3 meetings to go from the stage 2, stage 3, and then to stage 4. So once we actually have agreement about what we're doing, it's pretty quick, but it's getting that initial idea hammered out that took forever.
Yeah, and I just add to that really quickly. So, as Justin mentioned, we meet multiple times a year. So we have 6 meetings a year, every other month. Generally, a feature, if it goes for stage advancement, only goes 1 stage per meeting. And so, in theory, and this is not generally in practice, but kind of the fastest you could go through the whole process would be like 8 months.
Has anything ever gone in 8 months?
I don't know if it's gone that fast, but I have seen proposals, for example, that are for very, very clearly defined features that come in as stage 2 because they've come with a really, really clear use case. The spec text is already written. It is not controversial that this is something that we need. I'm spacing on the exact one. I know that a delegate, Mike Samuel, had a couple.
Optional catch went through very quickly.
Optional catch.
I'm a bit puzzled by the process implication there. I don't remember anything, so to speak, coming in as stage 2, just that it rapidly advanced to stage 2.
There's a few examples from the internationalization point of view where we bring things directly in at stage 2, which sort of segues for how do proposals work on internationalization. So we have a subcommittee where we review internationalization-specific features. This is things in the INTL object, so INTL number format, INTL date format, INTL collator, those kinds of things. And we review those proposals and check the use cases and check the implementability of them before we bring them to the full committee. So we frequently have proposals that come directly in at stage 2 because we've already done a lot of this vetting before we bring them to the larger committee. And it means that sometimes we can have proposals that go through the process faster because of that. For INTL, I find that the biggest bottleneck for us is getting the implementations because the internationalization APIs tend to have a lot of dependencies and are more difficult to implement sometimes because they vary greatly from language to language and region to region. So we tend to have a lot of proposals that get stuck at stage 3 and can stay at stage 3 for a year or more before the browsers have implemented them. Whereas I know a lot of other proposals that get stuck at stage 1 or stage 2.
And one thing I was just going to add really quickly is there is somewhat of an ambiguity in the stages. And so the conversation that Mark and I were having right now is actually a very healthy debate that can often happen around, like, there's the reality of how things go through, but then our understanding of how that applies to the stages can vary. And so it is not uncommon. We're a group of people who like being pedantic. It is not uncommon that during a meeting, we may actually stop and discuss the process and ensure that we're being fair to the process, that we're following all the criteria. And I at least like to think that it is to an extent a living thing, and we want to be flexible, and we want to have a process that creates a great language. So, even just this past week, I think probably almost a third of the committee time in the 3 meetings that we had were discussing a variety of different process changes that we're exploring for a number of different reasons, including potentially introducing more remote work that we could do, or more ways of meeting in between meetings, because one of the things that can happen, for good or for bad, if you bring something for stage advancement and someone points out something that you hadn't thought of between the 2 meetings, something can get delayed for 2 months, which is why things can take 3 or 4 years. So we're actively trying to think of different working modes that we can use to minimize the possibility of that happening.
So speaking of all of this process, and you mentioned the actual implementation part, how does the implementation process work, and how do you actually know that things are being implemented correctly? You can use my mic if it doesn't work.
One of the key criteria for actually landing in the spec and to getting it into stage 4 is that we have conformance tests. So the main project for that that's test 262, and that has a number of maintainers. Boku have done a lot of work on that. Sorry? A ton of work there, with Leo Bolter in particular contributing. And so having that, all implementations that go through should be 100% compliant with that, ideally. I think you can see a lot of the stats that there's still a way to go there. There is a project.
Oh, you can see them for yourself at test262.report. It's a website that shows each of the engines and how many tests are, what their compliance looks like.
All of you in the room can help with this as well, because whenever a feature is released, it normally comes out in browsers in early versions like Canary versions. Maybe it's behind a flag, so if you enable these in your browsers and try them out there, if you find any issues, if you find any bugs, or maybe you've just got feedback, maybe you like it, maybe you don't, please do provide that feedback. All the proposals have a repo on GitHub, so you can raise an issue there, and that's always massively appreciated. We see a lot of people reporting real-life things there, or you can file an issue on the actual browser bug trackers as well. So please do try and experiment and have fun.
Our organization is TC39 on GitHub, and you can see every proposal we're talking about, and the agendas for every meeting we're doing, and a few other things. So it's the easiest way to actually participate in the process.
Back to the implementations. During stage 3, that's where these implementations are being done. And quite often, it's often the case that we find that we're underspecified about certain semantics. And so implementation A will do something one way, and implementation B will do something slightly different. And it's during that process, either using test 262 or the test that those implementations write to validate their own implementation, that we find that there's some discrepancies, and we work through those discrepancies and unify things. And we're going through a proposal now where there's a little bit of unification around that. But that occasionally happens, and that's why we have that implementation stage, or stage is primarily focused on implementation, that we make sure that we're compliant with each other, we're compatible with each other, as well as compliant with what the spec says.
I always like to talk about weaknesses as well as strengths. Test 262 is an amazing piece of work, but it's important to understand that it consists of very, very detailed unit tests that go through the spec kind of in order and try to make sure to touch everything in the spec individually as a unit test. What it is not is an integration test. Languages have lots and lots of non-local and non-orthogonal interaction between features, and we have repeatedly seen non-conformance that was not detected by test 262 at the non-orthogonal interaction of different language features. So going forward, one of the things that I would very much like to see is some creative thinking on how to bring more integration testing to testing the language and how to do that without a combinatorial explosion. I think it's an interesting problem.
So are these repos that you've all mentioned, is that the best way to interact with the committee? Are there other ways that individual developers can get involved outside of being a delegate from their company?
There are so many ways you can get involved.
What?
Thanks for asking.
Tell me.
We have a discourse instance at es.discourse.group where you can ask questions, you can see discussions of sort of potential ideas or you know, kick around some thoughts you might have on the language. There's also, of course, GitHub. Each proposal is at tc39/proposal - the proposal name, and you can see all of them at tc39/proposals. You can contribute yourself as long as you have filled out our royalty-free intellectual property rights agreement, which sounds like a mouthful, but let me tell you, my organization has rather cautious attorneys, and they're like, nah, it's cool. So, you know, it's cool. We also are on IRC. We're on Freenode at TC39. Am I forgetting any? I'm on Twitter all the time. We got our Twitter handle back, but I don't actually know who uses it. So.
So contact you on Twitter specifically.
Yeah, just find me, it's fine.
Great.
Actually, a lot of us do follow looking for TC39 hashtag to see what people are saying and thinking about the stuff we're working on. So it actually is a pretty decent way to get our attention.
Yeah. We also have a process as the committee known as invited experts. So if you're working on like open source libraries or working on things that directly impact the standards that we're working on, there is a process in which you can be invited to come and attend a meeting. I'm working on one proposal right now for module attributes where I believe, but I could be mistaken, but I believe one of the people working on it is not a delegate. One of the champions is someone from the ecosystem who helps maintain Babel, who's building out examples of the implementation. And I won't lie, like it is a little bit of a black box to figure out how to get involved, but when you find those contacts and all these people who you see on the stage now can be in a place where you can start there. But if you have ideas and you can get a champion excited about it, there's definitely a lot of ways that you can help directly in creating proposals and potentially even come to the meeting. The OpenJS Foundation in particular is a member as a nonprofit, and we have within the OpenJS Foundation $40,000 a year travel budget to cover travel for people within the foundation. And we've actually paid for individuals who are not members of large companies who have been invited as experts to go and attend the meetings because the travel can be cost prohibitive. But there are ways to do it. And I think as a group, one of the things we do want to do, hopefully in the nearer future, is try to make some of this better documented so folks can figure out how to get involved.
Cool.
Another interaction point is that there's a set of calls that are set up, so running regularly for things like tooling, where we get the tools vendors all together, like TypeScript, Babel. If you have an interest in maintaining tools there, you could join yourself. There's also a frameworks call where, for example, React, Vue, and all these contributors come on to talk about how the new proposals that are coming up, how they may be shaped or whether they might impact these groups. And there's also the educators call. So this is all about people who are teaching the language. So if you have a responsibility for teaching people at your company, or an interest in that, please do join. And then you'll hear about all the new proposals coming up. And if you have concerns, maybe a feature is going to be hard to teach to people, maybe it's going to confuse them, then that's an excellent way to provide feedback and talk to other humans.
Speaking of that, is there, with all of the new things being added, is there a risk of the language being too cryptic for new developers? Ooh, you have a thought.
Yes.
Okay.
Yes.
Not if I have my say.
It's a continual battle, but this committee, I think, has been engaging in the battle well. But there's an inherent problem in the dynamics of any standards committee, which is there's two things being battled. There's two things in tension. One is, for any new feature, the benefit of the feature individually. And then there's the overall cost on the complexity of the language as a whole. And when you're the promoter of a particular feature, and even if you're not the promoter, when in the room we're discussing the feature, we very naturally are focused on thinking about the feature, in which case we're generally thinking about the value of the feature. It's very hard to maintain vigilance to guard the overall complexity budget of the language. And as the language gets bigger, the danger increases because each additional thing added is a smaller fraction addition, so it's easier not to see the danger.
There's also, so for the past, I think, 2 years, we've had a presentation about syntax complexity. And there's all of these very funny slides about how cryptic can you make your code. Leo presents this every time. And last year, it was just filled with so many question marks.
I like to do like triple nested ternaries in classes just to be like, did you know you could do that? And then people's brains hurt.
I think one of the other protections we have in the committee from the language becoming too complex is that in more recent years, or previously, the committee was populated with mostly implementers and a few other people. In recent years, the membership has grown quite a lot, and so there are now a lot more users of JavaScript involved. So there's a lot more regular web developers that are there to actively speak up if they believe that things are getting out of hand.
So for new features to come in, how often does it come from these just web developers out in the wild? How often do they come from community requests, and how often do they come from internally in the committee or elsewhere?
I think for Intel, we have a GitHub repository, which is github.com/tc39/ECMA402. 402 is the number of the Intel specification. And we get feature requests from users. And the more users that request a feature, the more interesting that feature becomes for us to prioritize implementing. Ultimately, these proposals are driven by the members of ECMA International. So for the Intel objects, these features generally have to be features that, in my case, Google clients need. But those are quite often align closely with the features that regular web developers need. So it's really good to get signals on what features users are requesting. And at least for Intel, the way that we do that is by engaging with users on GitHub, which also segues back to the earlier question about how can you get involved. If you go to our GitHub page, we have a calendar with our monthly meetings. We have a monthly 2-hour phone meeting, which you can subscribe to that calendar if you're interested and dial into those meetings.
So I think my claim subjectively is that at least 80%, maybe 90% of new features in the last 3 or 4 years have been done by developers and not implementers. I think that that's been the case recently. I believe before that there was implementers were more wanting to add certain features as engine developers, as language, VM developers. But I think it's switched in like the last 5 years.
And I guess one thing I can add as well, especially when we talked about stage one, we talked about the difference between coming with solutions versus coming with problems. And so I think that while the solutions may not be exactly what developers from the ecosystem had in mind, or even necessarily what we had in mind as we're still discovering the problem space, the problems that we're coming to solve are very much problems that developers are running into. And I think some of the work that we've done around modules is a really great example of that. Like being able to write modular code, very much a developer problem. What kind of weird solutions we need to come up with because of history, that may not be something anyone would have ever come up with in a vacuum. So it's a bit of a balance there.
So with all of these things coming into play, what are the goals for the committee, especially in like the next 5 years? What is JavaScript's identity in the next 5 or so years? Or more? If there are so many different answers, I'm genuinely curious, honestly.
So I think one of the most important things about the nature of the committee is that people on the committee represent different constituencies and have different perspectives and different long-term visions. Back, I think, 3 years ago now, there was a set of presentations specifically soliciting from committee members who wanted to present on this what their long-term vision for JavaScript was. I did one of those. It's up on YouTube. I recommend it. But the important thing about the diversity of goals on the committee combined with the consensus process is something really magical happens as we all negotiate with each other. Something will seem very good for some goals and will conflict with other goals. And when that conflict is unresolved, that can prevent it from going forward. But the thing that's being proposed is it's not that there's a particular technical solution that somebody's trying to move forward. They're trying to solve a problem. And when you run into those conflicts, it forces the people who want the feature to figure out how to redesign the feature so that it doesn't step on any of the other goals. And often these are goals that those people would not have had in mind if it was not for the discussions in the room and the need to achieve consensus. So I think we have a very, very good process. And the language, as it moves forward, really does succeed at advancing many different visions of the language.
I think one of the things that's also going on now is that, say, like 3 years ago, Node wasn't really involved in the conversation at TC39, and Node now very much is. We also have embedded devices that are using JavaScript. There's a new TC53, and you're talking about JavaScript for very, very small constrained devices, not necessarily wearables, but certainly that's one of the targets, and that's kind of a different ecosystem. Mark's involved in JavaScript on blockchain. So 5 years ago, JavaScript was about the browser, and pretty much that's about it. And we still have this mantra, don't break the web. You can't have a breaking change, but the conversation is now involving other ways that JavaScript is being used. And I think that's, like I said, coming forward the last 3 years, and I think that's continued to be the case moving forward.
Let us not forget my favorite places that JavaScript is running. Satellites in space, and Whirlpool washing machines.
So I think for myself, and Michael kind of touched on it, selfishly, my hope for the language over the next many years is that we have a lot of different places where we're going to run JavaScript. And I would very much like to have a language that we can run everywhere. One of the biggest risks that we have in the way that we standardize things is we don't standardize absolutely everything. There are things that are left up for the hosts and the implementers to make decisions on. A really obvious one is the specifier when you import a module. How do you turn that specifier into a path on the file system and then resolve that to actually get the resources? The language doesn't actually know anything about a file system. So this is left up to the host and the embedder to figure out, which becomes a place where we can have contention between a thing like Node and the browser. And that's something I've been doing a lot of work on within Node. But I'd very much like to see us move towards having developers, the people in this room, be able to like kind of write code once and run it in all these different environments and not need to know all of the different intricacies. And that's not to say there won't be unique APIs across these environments, but the core language should not be getting in the way of that.
I'll take a stab. From the internationalization engineering perspective, our team at Google is looking forward to building an IE10N framework, not just for JavaScript, but also for other client-side applications, including Android and iOS, and watchOS, and Wear OS, and Flutter, and Fuchsia. And we're sort of starting with JavaScript as one of the most popular client-side platforms, the web platform in general, and then sort of taking some of the lessons that we learn here and then applying those to the other platforms. So I sort of see JavaScript as sort of the leader in how you can build a great IE10N friendly platform.
So I think you can probably tell from some of the answers here that the wide range of answers that there is no singular vision. There is no dictator that decides exactly what it's going to be. Okay.
You sure?
Aki keeps us on time. She's very, very good. But that's also another thing is that JavaScript is not owned by any one person or company. And I think that's a really big thing about the reason that it's special, the reason that lots of people come together to invest in the language. People invest their careers into it, their spare time, but equally companies. These features that are coming out, they don't come for free. Companies are choosing to direct investment because they think that JavaScript is a safe investment for the future and will continue to grow and evolve.
And building on that, perhaps the real JavaScript is the friends we made along the way.
Aww.
Having talked about why this composition of lots of different goals has been so beneficial for JavaScript, I'll now also tell you just a bit about the vision I've been pursuing. When I joined the committee, the standard JavaScript was ECMAScript 3, and the committee was, most of the committee was trying to standardize on ECMAScript 4. When I joined the committee, I joined the rebellion against ECMAScript 4. One of my proudest accomplishments on the committee is helping to kill ECMAScript 4. The thing that we were designing instead, the underdog was at the time ECMAScript 3.1 became ECMAScript 5. And ECMAScript 5 is a rare accomplishment, a rare kind of accomplishment on a standards committee, which is it's subtractive. It gives the users a better language by making it smaller. And specifically, the introduction of strict mode. You can't break the old sloppy code, but the strict mode was an opt-in to create a simpler language that was better because it left out so many misfeatures. So the shirt that I'm wearing today really does express my vision, which is starting from big, messy JavaScript, find different subsets of it that can be enforced subsets that by staying within those subsets, you can have an improved developer experience. You can program in a more disciplined manner, you can program in a more secure manner, and you can compose programs that are written separately with less danger that they'll have inadvertent interference with each other. So in particular, I've been working towards a vision we call SES, Secure ECMAScript, which is one of the circles on this T-shirt.
That's a great shirt. I would like to see. Do you have that graphic on Twitter or somewhere where we could look for it? Okay.
I don't know that we have it on Twitter, but we have it.
Yet.
Yeah. Okay. Okay. Yes, it'll be on
GitHub
Twitter
or
shortly.
something.
Sure. Yeah. It's in the Jessie repository. The Jessie is one of the smaller languages here that we use at Agoric. It's not something we're proposing as a standard, but that's where this graphic is found.
Neat. So a few of you mentioned having JavaScript run everywhere across different platforms and space of washing machines everywhere. So because it's being targeted by so many different devices, so many different compilers, so many different things, how does that affect the design at all of how you have to move forward because it's starting to be everywhere and be targeted by so many things?
One of the reasons we have implementers start implementing these features at stage 3 is because we actually want their feedback about whether this is something that's possible in their engines. Because if we add a feature, not every language or not every engine can actually do the feature, then that's not really a feature. You can't depend on it anymore. So that's the reason. One of the reasons we require 2 implementations before going to stage 4 is just to make sure that everyone has had time to actually look at it, try to implement it, and it's actually possible.
Cool, that was a concise enough answer. Nobody has words. Oh, okay.
If no one else has anything to add on to that, so for the Intel space, there's sort of 2 places that you can do internationalization in your client-side code. You can either do it you can either ship the JavaScript directly to do the date formatting, for example, or you can use the browser engine. So by putting this into the JavaScript engine, we are actually able to make the JavaScript code that you have to ship a lot smaller. And then that's one of the motivating factors for having Intel in the standard library of the language. And it's implemented in a separate specification, so you can have a conforming JavaScript implementation without the Intel object. But at least for browser applications, this is a very important feature. So this is one way that we're able to provide this feature for browser users and not necessarily require it for all implementations of ECMA 262, which is the main language.
How often, I know we already talked about like how features come in from different places. How often do features come in based on other languages and other things like, I don't know, C, C#, Perl, anything?
There appears to be a lot of that recently. C#, Ruby, things like that we're adding those. And in a lot of cases, that's syntactic sugar. And we already have the capability, think about like arrow functions. We can do functions. We've been doing functions for a long time, but now we have arrow functions because that's one of the ways that people like writing functions. We got another language. And I think there's a little bit of a danger here that we have to be careful, because if we take every construct in every other language that we already have some way of doing that in JavaScript, we add it, and so now you have multiple ways of doing the same thing, it may become confusing. So
Or Ruby.
What's that?
It may become Ruby. Multiple ways of doing the same thing.
Yeah. So there is a lot of genesis of ideas for JavaScript, proposals for JavaScript that we see that do come from other languages. And go back to the discussion earlier where there's, people on the committee says, okay, this is what the syntax will look like, possibly, if we do this for all languages. And so there's this weighing of the balance of how much, because most of these are syntax kind of proposals. What is the syntax budget we have? We're running out of special characters, and having 3 characters in a row for a keyword is starting to get to be a little bit too much. Is this feature worth it? And so that's the discussion that you have. And again, as Mark said, it's not just that feature, but that in collective with all the other features.
And one thing to add on top also, the motivation may not come from other languages, but I think it's definitely an important thing for us to do as part of research is if we've identified a problem, we look at the solutions that other languages have come up with. Maybe they come up with a great solution that we can copy, but They may have also come up with a solution that absolutely didn't work, which we can learn from and not make the same mistakes. So I think that any champion who is really doing their due diligence is looking at other languages for, at the very least, inspiration when designing things within JavaScript.
The phrase prior art comes up a lot in proposals, like a lot. It's good. Research.
Well, we did have a question from Twitter, and the question was, what is the difference between TC39 and groups like W3C?
So there are a number of different standards organizations that standardize different things. So TC39 exists within ECMA and focuses on the core language, and just the language. And a really great example that can show a difference here is the console object. Most people, and myself included, debug by console logging. It's really easy and it works, and you put emoji in there and then that works, and you're like, oh. But the JavaScript language doesn't have any sort of idea of system calls. It doesn't have this idea of printing. So it doesn't have any output. You can execute and run things and put it out. Console has no place within the language. If we wanted to implement console in the language, we'd have to also implement like our own kernel for interacting with the system, which I don't think Mark would be happy about. I'll give it to you afterwards to add on that for Cess. But console is standardized at the What Working Group. The What Working Group standardizes a number of different things, including the URL object. And these are things that traditionally were implemented in the browser. Fetch is another standard that was made at What Working Group. But you're seeing other runtimes, such as Node and Deno and Cloudflare EdgeWorkers, adopting these web standards that are not from TC39 to make part of their runtime. We talk about implementers and engines. That's like V8 or JS Core or SpiderMonkey. These are the JavaScript engines inside of the browsers. But a product like Chrome is made up of a lot of different parts, of which the JavaScript engine is just one. There's the whole rendering layer. There's everything that has to do with accessing all the system bits. So W3C, for example, is where HTML is specified between W3C and What Working Group. CSS is specified at W3C. WebAssembly is specified at W3C. And these organizations have a different fast track to international standardization. They have completely different governance models. My understanding at W3C, where I've not done a ton of work, is that each working group charters their own charter and operates completely differently. So the CSS working group and What Working Group, the CSS working group and WebAssembly working group operate completely differently. I do think that, especially with the vision that I proposed earlier, there is a need now more than ever for these various organizations to be working together and thinking about a shared vision. And I think an interesting problem for the next couple of years will be starting to think about, like, hey, where are neutral spaces where we can all collaborate? Michael's working on a proposal for built-in modules, for example. And a big question is, well, who owns the built-ins? Where do those built-ins come from? How do we categorize those built-ins? And you need a lot of trust between different groups if we're going to expect other people to kind of respect it. And the flip side is there's a risk that if TC39 tries to over-specify and overstep, that people won't want to implement the spec. That is thankfully something that's never happened, but it is a very real risk. I think that every member on our committee takes we have a really large responsibility. Everything works right now because people are happy and working together. But that is fragile and could fall apart if we don't take that responsibility seriously.
I want to explain an interesting historical accident that
I love story time.
that really set us up for success. I mean, we really just got lucky here. The first few decades of JavaScript's existence, there was only one host, which was the browser. And you think about a language that's only being used for one purpose, and the thing that is, looking back on that, kind of miraculous, is that the language does not have many browser concepts in it and doesn't have any browser I/O in it. Even when the language was evolving only under pressure to serve one host, it did not, the boundary between the language as computational and the host as providing I/O was maintained. I think the only explanation for this, historically, because people didn't appreciate that property until there were multiple hosts, historically, the only explanation that I can see is what's called Conway's Law. Conway's Law is that an organization can only create technical artifacts whose communications structure reflects the communications structure of the organization. The language was under ECMA. The browser was under W3C. That organizational split, I think more than anything, is responsible for the language in the browser not getting too entangled, even when nobody was viewing the lack of entanglement as a virtue that needed to be maintained.
That's a really cool story, because I didn't know about the separation as much until you started talking about it, and that was great. Well, we are slowly running out of time. One last thing. Do any of you have a favorite JavaScript joke? One of my favorites, for example, not that I had any at the ready or anything, was there was a developer that said, "Hey, what is this?" And the other developer said, "Oh, I tried to call about it earlier, but I was in a bind." What is this? Bind, call, okay. Anyway, do y'all have any others?
You have one?
Yes.
Do you want to hear an asynchronous joke?
Yes. That was good. Yay! That was good.
You promise?
I've got one. How do you fix a JavaScript bug? You console it.
Nice. Well, I think with that, we're done. Thank you all so much. This was awesome.